It is time. Why? Yulia. Why is it not? Where is it? Why is it gone? The task text is just invisible. And now it's back. Okay. I guess OBS just forgot to load the font file. Yeah, so I'm going to do Rust. Do Rust. Do Rust. I'm just getting things open. Okay. I'm looking at number parsing. There's something cool that I saw. I mean, is it cool? I don't really know. It's interesting. It's an idea. It could suck. I have to go back to find it. This is, by the way, this is exactly the kind of programming that I think needs to die. This kind of module spam stuff, it's so over-engineered. Okay, that's not what I'm looking for. I'm looking for this. I thought I was clicked on that. Like, look how many files there are. Some of these are also crazy files. You know, options is... Okay, I want to pull this out. Options, by the way, doesn't actually do anything. You would think this is all doing something. This is all nothing. All of, like, the logic behind every bit of this is in a different module. So this file exists to just reference things from other files. They're not even here. Anyway, this is the maybe cool thing that they do. They do parse number. I have to go find it. I mean, I say cool, and then I'm like looking at like 10 levels deep of 10 layers deep of template functions. I mean, this is what C++ should die for. I mean, isn't that good to avoid one big file with credit systems? They are overdoing it, man. This is reading a byte. This is reading a string and converting it to a number. And in fact, it's not even doing anything clever. It is reading a string, saying, oh, is that a 1? Okay, we add 1 to our value. Oh, is this a 2? Okay, multiply our current value by 10, add 2. That's what this is doing. This is what they're doing. Do I have a multiply? Do I need to multiply? Yeah, right. So first thing, multiply it by your radix, which for hex is 16. For decimal, it'd be 10. And then you add the value, minus 0 as the string. So this is effectively doing minus 30. 0 is 30 in hex. I say 30. I really meant ASCII table. I wish ASCII table had a dark mode. And maybe a little bit bigger. So 48 decimal, 30 hex is 0. So if you take 0 in hex, which is 30, minus 30, you get the integer value of it. 9 minus 30, or 39 minus 39, right? They have not done anything clever here, and yet, my god, I have to jump through at least 5 files, managing a web here of connections to figure out what's happening. Okay, so Mantissa. They also... Mantissa? What are you calling it that for? Whole part. Call it the whole part. Because they call this bit the fraction part. Fraction. Or... I mean, they do it somewhere. I don't know, like, but that's what they do. Hey. They are subtracting a value from the byte, so you get it in normal. They multiply it, and then they add it. I mean, like, literally, like, Mantissa is equal to Mantissa multiply by the radix, add the value you just read. 600... 1,000 lines of code to do that. The one cool thing, though, that they do, which I think was actually cool, is, and it's, I would think it's probably always faster. You know, in my mind, it makes sense. It would probably always be faster. I just have to remember where it was. Actually, I think it was already here. Okay, no. So they do algorithm. It's called algorithm. Algorithm is in integer, of course, because if you want to parse a float, you need to include the whole... If you want to parse a float... Wait, does this even have anything? Okay, I don't know. Try parse 8 digits. So essentially they're taking the bytes. They do a whole wrapper on top of byte vectors, which I think is just totally unnecessary. Because ultimately this, like, PQ64 is just to reinterpret an index as a 64-bit number. Just take 8 bytes and interpret it as a number. Which I think is sort of cool. So right here, you can see with the hex 30s, those are 0. So they read in 8 digits, basically 8 digits at a time. And they will, this is all kind of, Okay, well, you take the value, you subtract everything, so everything is now a 0 becomes 0, a 9 becomes 9. They multiply it by the radix, which is just 10. So they multiply the value by 10. And then they add the value shifted 8 bits. And then they AND it with the mask. And they multiply that by this. Jeez. This underflows in, and also I don't really like this either. This is just weird. I feel like it should be sort of strict in the sense that it should be, I don't know, it's doing certain things that just seem strange. Let's see this. Oh, does this work? No. Oh, maybe this works. Nice. The case involved, in one code execution hotspot, the case involved code that had to convert 8 decimal number ASCII characters to a number. Okay. Unroll the loop, sure. Eight loads, 8 subtracts, 7 multiplies. We bitwise and each number with OF. We can put the ASCII character to its corresponding decimal number for that number character. Okay. So you don't even have to subtract, you just, or I guess this is a concept, and it. Yeah, a bunch of 30s, and 1, 2, 3, 4, 5, 6, 7, 8, 9. On Little Indian, why are they showing it backwards? Don't show it backwards. It's just weird. Okay, this is just, why did you do that? Why'd you do that? Why'd you just say, oh, let's just think about it all backwards now? Why? The low digit in the ones and the high digit in the tens. Sorry. There was and all the high digits. High digits. What are the high? The high digit is stored in the byte right of the low digit. Okay, so the ones place is the low, tens place is high, hundreds place is low, thousands place is high. I think that's what they mean. This is a weird interpretation of a number, though. I believe we group numbers in threes. Bitwise and all the high digits, and then multiply the high digits by 10 to get them into the tens position. Right, shift the low digits into the same spot as the high digits. Add them both together. Isolate the highs, multiply by 10. The thing is, this also requires it to be reversed still. Are they reversing their bytes? Like, why are we... That's not what's happening. Like... Multiply by the radix, add the value shifted 8. Okay, I mean, I see it. Extend the concept to combine the numbers into larger groups. Represents decimal number in a byte. Enter the decimal in the tens position. Lowercase represents decimal in the ones position. Numbers are in range 0 to 99. Now isolate I number. Use 7F, which encompasses number range. Right. Multiply by 100 to move high number into thousands and hundreds position. Shift the low number over to tens and ones position. Okay. It's a bit weird though. One load, assuming you can load the whole thing. I mean, it would just be a reinterpret, right? 7 bitwise ands, 3 shifts, 3 adds, 3 multiplies. That doesn't seem much better. Equal cost of non-multiply operations. Okay, sure. Stop with this stupid load order. Okay, wait, so they read halfway down this paper and then stopped? Why didn't they use the second one? Unless this is all just the same thing. You multiply by this, shift 8, 16, 32. Do they do all those shifts? 8, 16, 32. Okay, I guess they do. Okay. So operations, assume all that's pre-computed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I count that right? Seems like there's one more. Python in the morning, Rust at night, you're gonna lose your mind? What? This is cool though. Why did they like number them out though? I do like this though. This is like shader stuff where you try to set it up so you can do basically in powers of 2, right? You can reach 8 by, you can divide 8 into 2 3 times, right? Poor Norma to Bevy. Off day. Yeah, I'm not doing the game right now. This is something else. I'm calling it Rust Friday. Because I should probably do it more often. Yeah, why do they have one more here though? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I mean, honestly, like this just seems like why I don't know why you wouldn't just write the code out like this. Not knowing about Bevy earlier seems like it's bothering you. No, it's not. It's really not. Bevy is a failure for what it's trying to do, honestly. Modular. By the way, our modules rely on no fewer than 4 to 5 other modules every single time. And some of them just have dependencies that are not even necessary. Yeah, this is like shader code, right? Like if you even look at where the Fs are and you just think about what's happening, essentially you're taking these Fs and shifting them down 1. And you take these Fs and shift them down 1 is the idea. Oh, well, this is already shifted, I guess. But then by this point you're left with the result. If you drove yourself game see. I don't, dude, I'm so, it needs an editor. I think a game engine should totally support being like full interaction. Like if I see a piece of code that the engine is running and I want to change it, I should be able to do that. There shouldn't be a single hidden function. Generally. And then you need an editor on top of that. So when you don't need that stuff, you don't need to work with it. I mean, at least like when it comes down like making a level or like positioning things in space on a screen, you need something visual. It's just a total mistake to not create that. something. Being known as that engine vibe coders use. I don't know, I think Rust is kind of weird. I can't tell quite yet if it's like high level or low level. I mean, it's low level in the sense that if I want to reinterpret 4 bytes as a single, or 8 bytes as a single 8-bit number, 64-bit number, I could just do that. But I mean, even like other languages still have that. That aren't like memory managed, or memory is managed for you. Telling you you're missing out on the friend slop window. Mecha Chameleon. I mean, it's cool that you get to paint. But also, I feel like you gotta be... The characters might be too big. I don't know. You can make this in one shot with Fable. I don't think so. Texture painting? Not even texture painting. This is like model. This is a mesh. What's the term? I don't even know. I need a modules from a message for you to stop reading in half. Okay, I say out loud, but I've already read the whole message before I start talking out loud. Someone did a one-shot generic core again. Where are the guys? There's got to be guys in this picture, right? Or they just took a picture without any guys to make it look like they can hide. This is probably the only one you might be able to get away with, as long as someone doesn't think that you could hide in the meat. That is definitely pure friend slop. I think I struggled for days to decide if you should learn Blender or not. The developer is Lemurian1224. Hi, Danilin. Have you noticed how society treats you once you become schizophrenic? I have not noticed. I have not noticed being treated any differently. Also, I don't understand this. Like, he says recall our high school linear algebra and just pulls out a fucking equation. Where did that come from? Seems like botting. I don't want to know what it's at. I still don't think I really understand this one. We're grouping up the numbers, but I wish there was more about, like, the bits. The bits. What are the bits? What's the bin of 10? I guess 9, actually. Is it Giga Chat who's flooring us with channel points? Yeah. New cousin video found. It's Instagram. What are the odds that I'll be able to look at this? Okay. How many channel points? Someone said that they were like, I don't remember. It was, I think it was probably, I would say it's probably at least double whatever Yelia has. So if Yelia wants to share how many they have. You're a mod, can't you tell? I would need a bot to, like, look at that. That's not a thing that Twitch just lets us look at easily. We need a bot to, like, go through the API. Like, you know, I think it's probably like 200,000. I think you might have said quarter. Quarter of the way there. Can I do can I do something? Can I do something? What the fuck is that, man? Where'd you get that from? Don't put me on AI, dude. I can't show it. I can't. I'm not putting it on my screen. You can find out. I'm sure you can access it. You can, I allow you. I'm not putting it on screen. I guess I will forward it to you, because I don't think... Never mind, don't send it. Jeez, man. So, okay, everything fits. I really want to, like, rediscover this math and why this works. Because this guy just has to feel himself and talk about Little Indian alignment and just look at everything in reverse for some reason when it's just totally not realistic. You said his emote? No. It's not. Put me in AI. What? No, it's not happening. Let me hang on. Let me look for something. I have a self-portrait. Where would it be? Is it pinned? Right, and where's my do you have I DM'd it to you? Why do you not want to show it on stream? Because it's AI? That's why. But I have a self-portrait that I drew. I'm trying to think of where it is. I mean, it's in... I have... Oh my gosh, I'm gonna go look for it. It's in a box in my room. I'm sure it is. I'll be back. Okay, why is text just not loading? Let me check my Goon folder. Self-portrait. Yes, I've drawn myself. Okay, I'm gonna go look. I'll be back. Okay, I found my self-portrait, but it is not the one that I was thinking of. So there's actually a second drawing of me. This is not the one that I was looking for. There's actually another one though. Because the thing is, the reason that I was reminded of it is because that image kind of looks like it. The one that Danilin has produced. And then there's the picture. That's the picture I drew it out. I drew it from. Okay, but now I need to find this other one. Jeez, there was like a bunch of this pencil graphite triangle on my wrist now. Girl told me I was impossible to draw because my face was too symmetrical. There's that. That's not the one I'm looking for though. It's on my... I think I know where it is now. It's on my YouTube channel. You still have that ear injury? What ear injury? There it is. Did I say I drew it? I didn't draw this. I didn't draw that one. Someone drew that. That's the one I was thinking of. But there's actually... Nah, there's a pencil one. Okay, now I need to go... Because this guy sent it to me directly, I think. I gotta find it. I gotta make sure I save it, because I don't know if I've actually ever saved it. I'm scrolling through Discord. Man, it's so far back. It's gotta be here. Dude. I'm getting close. It must be very soon. Damn. Was that it? Oh. I think that was it. I thought there was a pencil drawing of it, but I didn't see the pencil one. But I gotta make sure I save these. I found them. There are several versions of it. There's a really messed up one. I gotta save these all. This is some very... Alright, I found them. Okay. Alright, I don't know how to... Let's try that. They're opening. What is this? I don't need that. What? I'm not doing this. Just no. Huh? I don't understand why. Import? Stop. Just... No, just stop. Just open the freaking thing. There's this one. There's this one. It's the original one. This one. These are like... It's from like 2019, 2018. I got them saved now. Okay, something's fucked up with my computer. Something's fucked up with the computer. I think I probably need to reboot. I don't know why. But it seems like something fucked up. I've got to wash my hand. This, like, pencil stuff. They're amazing. Yeah. But I could swear, like, it was that, but, like, as a pencil drawing. And I think the same guy made it. Put a virus in your computer that deletes your Undertale save files. Okay. I'll be back. I'm back. All right, but anyway, that is real art. That's real art. Dude, stop. Stop. No. Please don't do that. How about you draw something for real? You could draw something that looks better in the exact same amount of time that it would take you to get online, type it in, wait for the result. Oh, is this the math? Maybe it makes sense now. No, never mind, that doesn't really make sense. Hang on, so if I have... I'm just gonna write it out. 5,824. I need I actually need 8 of these, so 7, 6, what, 0, 8, 0, 9, 8, 1. So no 3. I'll do a 3 there. Linux Mint doesn't have MS Paint like software bloated into it. I'm going back to Windows. Okay, so that's a string. Now, if I were to look at... String argument without an encoding. It just does that. Okay. So I need to make it bytes. Actually, I think it should just type that. There we go. Okay. So if I had to do s minus byte, that's effectively what this is doing. Unsupported operand for bytes and bytes. Okay. Int of s. Bin of s. X of s. Observe my message. I don't want to observe your message. Who is that, dude? That's just Anime Man. I would like to work now. No more AI. How do I interpret this as a number? Int from bytes. Awesome. There we go. Okay, so I'll do in this minus 30, 30, 30, 30, 33, 30, 30. Right. Well, or I guess I could just do this. I'll just track this. So end it with this. See if there's a lower model so I can make it locally. Make what? Okay, I gotta take the dog out. I'll be back. Dog? I'm back. It requires too much RAM. A blessing in disguise. What is this number? The bin is 9 is that. That's 10. A is 10. That is... When they do this, does it matter which way it goes? I think it does, right? I'm assuming if I try this, it's going to be the wrong way because he's converting everything into Little Indian for just an unnecessary reason. Okay, so let's try this. So this is the number. Okay. So that's N now. Which it feels like it hasn't done anything. But I guess it shuffled the bits around. Yes, what I mean to hit again. Things are being grouped. But an awesome alternative just to find a way to make it work. You don't have to. Alright, so this should be the thing that apparently just, like, it's done. Yeah, so that just didn't work. That number is way too large. So... Oh, is it because I started by subtracting this big value from it? Well... Try again. No, that still is just not right. In fact, I got the exact same result. Is it because this would be... No. That wouldn't matter. How did I get the exact same number? Oh no, I didn't do minus. Never mind. Make sure this is correct. Yeah, all the threes. Why do you hate so? That's not what I hate. What is that garbage? What is that useful for? Apparently these operations can just convert a string representation of a number into the number in binary using much fewer operations. It looks like it didn't like, I'm like, this is probably just because of the order of things. I'm loading it in as little Indian, which the number is actually loaded in as a big Indian. So let me, you know what, let me just try that. Let me try flipping all the bytes around. I would just type in reverse, I think, or I would do that. Okay, so I reversed it. No. Wait, it's like kind of there though, actually. The 0893 made it through. And then the rest just got kind of obliterated. Did I say 0893 made it through? You know, I'm just going to try rediscovering it, so... So technically I can just AND it with that. So if I do in and... is that right? 4 there. I think I added one too many. Yep. 4 there. So I do that. I would get, looking at the hex interpretation. Oh. No, I was right. There. Okay. So 582408993. So they're there. Now the idea is I would have to collapse that down into just its plain binary. So if I think about every operation that I'd want to run, I would like to do... Yeah, I guess I can just think about like which halves I'm doing first. So I'd like it to be that every single one of these basically becomes a multiple of 10. So if I look at 0903, the operation I would do there is to get 9, multiply it by 10, and then add 3. So I get 93. So I guess that would look like doing... But I also can't really do it that way because I'm limited to... I wouldn't be able to do that at the top. Also, the hex is kind of like dropping a 0 at the front. This hex... Let me see what this has. Really, that's it? Okay. Okay. What I could do is I could pull out all the 10s. So I could try pulling out the 10s. So let me try doing that. Let me try doing N. Jeez. Let me do like, just say 10s is going to be 1, 2, 3, 4. 1, 2, 3, 4. What? Oh. Duh. So the first thing I want to do is I want to do, let me say N0 is equal to N. Let me say N1 is going to be N0. And I'll say 1s. 4. 1, 2, 4. And 1 is going to be N0 and 1s. Okay, so now I have that. So tens is that X 10s. So what I would like to do is to pull these ones out. So X and 1 and 10s. Oh. Yeah, so 10, that's not correct. 10s would be... Okay, show me at 1. So I'm looking at... Why was that wrong? When I get that... This one, skip this one, grab this one, skip this one, grab this one, skip that one. Ooh. Okay, hang on. Let me think about it the other way around. Okay, I need to get like another... How do I get another digit here? So this is the... I have an 8-byte nut. Wait, how many is 8 bytes? One, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 8. Yeah. Why did N1 and 10s delete each other? Oh, because I'm obviously just reading the wrong thing. All right. Let me just try this. So this is N1, but I technically need another 0 at the front here. So I want to have, I want to pull that one, skip this one, pull that one, skip this one, pull that one, skip this one, pull that one, skip this one. This is what I want to do. So basically I'm going to take these numbers, shift them right on the next one, and then multiply that by 10. That's my idea. All right, I've extracted all the 10s. So I want to combine them with the number below them. And then, well, I think, yeah, what I want to do is I want to shift it there. Shift them onto the spot. So it would be 4, 8. And then multiply that by 10. And then, OR them together. I mean, not OR them, add them together. But the problem is I would have to do 2 masks. How do they pull 2 masks out of this? I mean, I guess if I know how I'm combining it, okay, there might be like an optimization here where I can just ignore the noise that's gonna come out from this. So I'm gonna try it. 2 will be N1 and 10s. Shift that 8. And then I would want to multiply this by 10. Technically that. And then I would add this. Oh, geez. I would add this to N1. Okay, so has the ones place worked? I should have 93 is 5D 93. It is. And then I'm just going to ignore that 9. And the next one would be 8, 0 and 8, so that's just still the same. And the next one should be 24. So it'd be 21. That doesn't seem right. Did something happen? Am I thinking about that right? I think I confused myself about where I'm looking. I think I'm actually looking at 18. 18 is 24. And then is 3A 58. Okay, so I have all the bits. I have shifted them down correctly. And then okay, so let me try to mask out what I know is correct. So boot Mr. Beast 500 million stream. What? Okay, so what I know is correct. Let me start with just 1, 2, 3, 4, 5, 6, 7, 8. All right, so I know that these bits are right. These bits should be right. And then these bits should be right. These bits should be right. Okay, I cut off a piece of that I didn't mean to cut off. Did I? Oh yeah, I definitely did. I meant for that to be like that. Okay. So I've got it closer. Okay, and then I want to look at the hex of N2. Is there a way I can format this to like, okay. Python left pad hex string. It's like this. F format value X. What is this formatting? Left pad, number of zeros. What the hell is this? 42 with 4 leading. Zero, what is that? 16. All right, good. Good. Boot Mr. Beast. Oh wait, I already read that. He made a mistake and started by starting the stream around 200. Okay. I don't know what he's doing. I don't know what's going on. Okay. So I've gotten there a little bit. I do have an and, a shift, a multiply, and add. So there's 4 things. I've done 4 things. Which I guess is like I'm already halfway there. So to interpret 8 digits, I could just do 7 multiplied by 10, 8 subtractions, and then 8 additions, I think is what it would be, right? Is that what is that the math that he came up with? 8 subtracts, I guess 7 adds, 10 adds to the index into num array. I guess if he counts really all of that. But that should be the unrolled loop. 8 adds to the index. Okay, so you wouldn't count that. Okay, I'll just count it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, this guy can't even count. He's saying this is 31. I don't know how he counted that. 8 adds to index into... You're not... No. 1, 2, 3, 4, 5, 6, 7 adds. 1, 2, 3, 4, 5, 6, 7 multiplies. 8 subtracts. 8 loads. I wouldn't even call these loads. I wouldn't really call these loads. But sure. Okay. Let's say they were loads. So I've done, at this point, N1 was, what? One, 2, 3, 4, 5. I feel like I'm kind of halfway there, though. All right. So that would be this one. And then I think the idea here is now these groups need to be multiplied by 100. Right? So this would have to be 800 added to the next one down. Did not realize I was in a steering levy and was asking, okay. Why are you doing that? You just had a feeling that was the lobby you needed to ask. Okay, so let's say N3 will be let me just start with this again. Well, actually, no. Leave all that. Okay, actually, I want to try doing this without that. I want to try using the one that has some extra stuff. That you would want to go away. It was sunshine bread, and there's a whole weird thing going on with that. What? Okay. Yeah, what I would be doing is I'd be shifting it down so that these two things overlap. But there are zeros in there. There are not zeros in there. I don't know who that is. I don't want to know. In4 will be in3, and so I'm gonna do the same thing again where I'm just grabbing these sections, multiplying them by 100, and then shifting them down. So I would grab this one, this one, and then that's what I do. Grab these. I think I can skip. Yeah, I should be able to skip the shift in this case. So I'll just, or I can't really skip the shift. I have to do it no matter what. So I'd move it down 8, 16. Multiply that by 10, and then add n2 or n3. Right, so now this spot should be, so now AD should be the 3 digits. Actually, it should be 4 digits. $173. Oh, I multiplied by 10. No. I'm supposed to multiply by 100. I don't know what 100 is. So I just multiply by 100. Now I can see what this is. All right, so it end up with 037D, which in this case is 893. And then I would have 3A should have been moved down, so I guess I'm looking at 16C. Okay, so I should have gotten not that. Did I shift it correctly? Where would they be at? So I should know at this point that these 4 are there. And then these 4. Okay, so I'm looking at 16C0. $5,824. And then 0,893. Okay. So then, you know who that is, dog. You know who that is. Does this make sense? This might be like too many ands though, right? Well, I guess in this case, N3 could be probably collapsed down to just doing N2 and that, and then N2 and the other one. So I have the 4 chunks at this point. I just need to combine them and then do that multiply by that really big multiply. It's perfect. Dude. I'm gonna block you. I'm gonna block you on Discord. You're gonna make me. Rhett, you're okay. Go get him. Go get him. You're so mean. This is definitely a reduction amount of work for sure. So then what I would need to do is do N5 could be N4 that, shift it all the way down to 816 2432. Jeez. Shift it all the way down to 32. Multiply that by, this is the thousands place, right? I think it's actually, add 2 more, the 10, this is the 10,000s. Right, because we start with the 4. The 4, yes, a 10,000s place. 1, 2, 3, close, 1, 2, 3. And then I would add N4 and just get those. And there's the number. Cool. Canada versus Bosnia. Can I could get banned in Game for Hope stream? You get a gifted sub from that channel. All right, let me count it up. So I'm gonna start over by having, or I guess with like n0 equals int from bytes s. Good. So the idea is n1 can be Game Info Hope is sub in chat. Yeah, it's been that way. I was gone. I got a follow an hour ago. CMEX B Temhote. Thanks for following. I must have just not been on my computer. He's gold. Damn. Okay, so I take N0. I end it with 1, 2, 3, 4. 1, 2, 3, 4. Actually, I'm only taking these ones, right? Yeah, I'm only taking these ones. Dog. Moving it down to 8. Why do you make me do this so many times? This dog makes me take him out so much. I will. I will. Hang on. And then I want to end that with skip that one, take this one, skip that one, take this one, skip that one, take this one, skip that one, take this one. Okay, so I have done 1, 2, 3, 4, 5 operations. 5. I mean, that's pretty good. Okay, I need to take the dog out. I'll be right back. Even though I'm sure he doesn't actually. I didn't stop the music. I'm gonna take a nap. All right. All right, so that's N1, and then N2 would be doing this sort of again. So I'd be taking I should be taking these bits and shifting them down into there. And I'd be taking right? I think I'd be taking these bits and shifting them into there. So shift that 16. Because of how it is scattered right now, I probably could. Can I actually combine a multiply in this? I don't even know if I can do that. I actually don't know if I can do that. But these would be a hundreds place. Then I would add these bits and these bits. Okay, so if I did 16C0, so now there's my two parts, and it would just be this again. Speed 32 times 10,000. And then I'm just pulling out the bottom 4. And that would be an 8-digit number in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wait, did I count that right? Hang on. It's the same number of operations every time. 1, 2, 3, 4, 5, 5, 10, 15. They're counting 10. I mean, it's kind of just like, this is what's kind of crazy about it. How do those values work out like that? Because this is the first thing. We take the raw, we convert the digits into their individual decimal values, binary values. You multiply it by this, and then you shift the whole thing over. Could I just do that. Could I do the multiply and then the shift? Because there's not even an add here. He's taking an add every time. No, that one just kind of doesn't make sense to me. Because a shift means you're just dropping information. The multiply isn't actually combining anything. So how does that work? Temporary. Multiplied by 256 is the same as left shift by 8. Yeah. I guess this is just a case where because you're in a certain endianness of the binary, you can combine a shift and a multiply. You can combine a left shift and a multiply. Those two are equivalent. As long as your left shift is a power of 2. I don't actually know which way it goes. Can I combine a right shift and a multiply? Okay, I sort of can, because I could actually turn that into... I don't have to shift these bytes down, I can shift the lower bytes up via a multiply. So let me see if I can figure that one out. So starting at N0, so I think the mask is always required at the start. So let me try that. Because I can kind of combine the multiply by just taking these ones and moving them up. And then once everything is on the left, then I move it all down with one right shift. Let me make that. Let me just try to see if I can make that work. So let's say N1 will be N0. Let's pull out the lower sections. So it'd be like this. So this gets me all of the ones. And I guess it's kind of weird because if I have bytes sitting at the top, oh no, I'm like actually guaranteed that this is fine. So the first time I do this, the grouping could only be between 0 and 100. Right? So I'm totally safe that I'm not going to have an overflow on this first one. So I can take this. Shift these up 8. And I could add that. But is this fewer? I could add that to 1, 2, 3, 4, 5. I still have 5 here. So I actually just moved this shift. I didn't do... I'd have to combine an operation. I think technically I can drop the and on the first call. No, I can't do that. I could combine both of these masks into one single mask. Let me just try that. Also, what is N0? So N0 is just the original byte value. Okay, I'm just gonna count it as I go. Every operation I'm gonna run as a separate number so I can just count up from there. So the first thing I want to do is I actually want to do N0. Right, there's the first operation. I've pulled out every number. So now what I could do is I could multiply this whole thing by 10. Shift it up and add it to itself. So be a multiply, a shift, and an add. So I'm at 1, 2, 3, add 4. I'm at 4 operations on the first one then. So let's do N2 will be N1 times 10. Right? Okay, so this would make something like 5A is going to be 90, right? Multiply, shift, add. Could I combine 2 multiplications? Because if I want to shift up, if I want to shift the lower bytes up as they are, and I specifically want to this is where you get the 256 and 1. That's where you get that from. Okay, so let's say N2 is going to be equal to N1 times 2561. So the 3 has stayed in place. Myself with a number. The 3 stayed in place. I mean, I say the 3 stayed in place. What I really mean is that it stayed in place, but then it moved up 8. But it's also longer. So I'm going to I need to take off the high bits here. So I'm just going to say N2. I'm not going to count this as an operation because this would technically not happen. Okay, so I've taken them off. And now I'm left with this. So I started with that and now I'm left with this. So the idea is that I should have pushed up the idea was this is a combination of multiply by 10, shift up. Actually, would it be a combination of that? I don't know, because I see 27 and that just doesn't say 93 to me. And I would expect to see just a plain 8 as well. And I don't see that. Sounds like apparently this is now where the groupings are. But that isn't actually true. The groupings are on the other side of that. Yeah, okay. Okay, so no, that did not work. Somehow I want to multiply by 10, so I take all of the numbers, every bit, and multiply it by 10. Let me just look at that. Let me just see what multiplying by 10 does. Okay, so every two bits now is a multiplied. So 32 would be 50, right? 5A would be 90. Okay. So now the bits that are correct are going to be this one, this one, this one, 14. Let me check 14. 20, minus of the string. So a 50, 20, a 0, and a 90. So then the idea is, can I... is that possible to merge into then doing a shift up? Do those combine? So I guess let me see what the result would be then. So the result would be to have n3 be equal to let me just keep it as clean as possible. Maybe the equivalent to this plus n2 no, because these ones have dropped off, so it would still be n1. So that'd be the equivalent. $58, $24, $8, and $93. So if I can see these bits, by somehow combining a multiplication here, so I'm trying to figure out how to make, I'm trying to figure out how to make n3 with what n2 is right now. Or times 10 times 256. And then you have the 1 at the bottom to keep that one as it was. still just don't see it. I see only the 3 at the bottom. Well, it's actually the 32, the 50 became 50, but the 50 is now shifted out. It's overflowed at that point. I mean, I could just do n1. So n2 is still n1 times 10. And then I could do n1 times... I might not even need the mask. I could probably just do shift the whole thing up. Okay, I definitely know that I can, I'm sure that I can probably combine these. I think I can just do the N1. Let me see. I have to make sure that this is... I'm not getting anything extra. Try that. I'll just make sure these are always... So my expectation is that I have... Oh wait, I just like ignored N3. I meant to do N4 was N2 plus N3. Which N3 is locked in as one operation. Alright, so I see 5D. I see 08. I see 18. And I see 3A. All right, so I have these groups now. But the bits are kind of really messy at this point. But I am on 4 operations, I guess. So N1 was the first mask. N2 is N1 times 10. N3 is N1 shift 8. And then I did N2 plus N1. Or N2 plus N3. But I suppose the difference here is that I kind of just... I have it now that I have N1 times 10 and N1 times 256, basically. So I would have... This is basically what I have, right? So if I think about it, I am actually just doing... Technically, the operation should be the same as if I just multiplied N1. Is N2 a mask? N2 is not a mask. I mean, it should be the same as if I just did this. If I just did N1 times that. So if I see... So that's N4. N4B could instead just be N1 times... 256. Wait, no. N1 times 10. So this is 10x plus 256x. So I should be able to add the fronts together, right? I'm taking 266 copies of N. And then I'm just going to be sure that this is a mask. Let me say... Wait, right? Did I not... Is that not the same thing? Doesn't that simplify just add these two together? If shifting by 8 is the same as multiplying by 256, they are equivalent. Why can't I add them together? SpaceX IPO'd. Cool. Yeah, right? I've gotten the same number. Okay. So now, if I start with n1, so this is n0, x of n1, n2 can be equal to n1 times 266, and make sure it's just masked. $1.7 trillion. Sorry, my bad, 1.9 trillion. The first trillionaire. Did it just happen? Didn't I say the strategy is you wait for it, you sit there, you wait for it, you buy as much stock as you can as soon as possible, and then you wait like a few minutes and sell? Instantaneous profit. Okay, so now I've got something interesting happening here. I've got these numbers. Here's my numbers. I love this guy for the wrong reasons. Okay, so I combine a multiply by 10 and an add. Or I combined a multiply by 10, an add, and a shift, actually. It's all in there. Now I'm technically at 2 operations, and I've already done. I've just done half the work. 2 operations. Okay, cool. So that's good. He's the best Overwatch player. Everyone else on top of him and rank is cheating. The issue is that the number has like messy bits. There are bits that are just kind of nothing. So I'm gonna freehand now. I'm gonna say that N2. I know at this point that if I would not be able to do this again. Because what I would like to do is I would like to multiply the whole thing by 10 again, basically. Or no, I think yeah, I would multiply the whole thing by 100. So largest value I can have up there would be 99. So I guess I'll see what 99 is in hex and just 63. So if I were to do times 100, yeah, so I need at least 2 more at the top. So at this point, yeah, I think I would not be able to get around a shift down. So shift it by 8. So now hex of N3. Now I've got 2 bits free at the top. So then the idea would be to just say, yeah, N3 times 100. And the issue is that I may end up with too much mess now. It might be too messy. Because I've just, yeah, I would be rolling up into bits that may not be usable. So Yeah, I mean, I've already got a problem because I know that 3A 58 has to become, if I did 58 times 100, yeah, right. So I would know that this should be 16A8. And I can see that I have 16C8. So bits have kind of flown into this one that should not be there. But I am at 2 operations now, with 1 mask and 1 multiply. Okay, so let me say N3. No, N3 is going to stay where it's at, I think. Though... Okay, let me consider what a right shift is. Technically, this is going to be division by... A right shift by 8 is like a division by 256. So I could say N3 is N2 shift that. And there's N3, where I have N3B, which would be equivalent to N2 divided by 256. Which is going to give me, yeah, silly float. So make sure that's an integer. Okay, just do integer division, please. Just give me integer division. You can surely handle that. Okay, there we go. So now I have N3 and N3B. And then technically what I would also do is multiply this by 100. And I would add them together. Okay, so let me think about this. Start back. Let me just get a reminder of where I'm at. N0, N1, N2, and N2 is the exact same thing as doing N1 times that. Right? Okay. So now I might say N3 will be N2. I'll write it as a division. And then I would like to then say N4 will be N3 times 100. This is supposed to be 256. N4 will be N3 times 100. Can I merge these two? If it was like times 1,000, I could merge them. But it's not the case now. Oh, also I'd have to mask at this point now too. So let's get that, and at this point I have to mask because I have bits that are wrong. because otherwise those bits are just going to interfere when I do the next multiply. So now n5 would be n4 times 100. Then I'll do n6 would be n4 plus n5. No. Wait, no, I'm looking in the wrong spots. That's 9393. What did I just do then? Did I make a mistake? It's funny, spell checkers are underlining the word trillionaire with red. Okay. That's odd. Alright, what did I go wrong? That's N2. N3 is the shift. N4 is the cleanup. N5 is the multiply. Let me just make sure these are correct, I guess. So I need to see 16A8 and then remind myself the number, and then I would need to see 800. So 800 there's 800. Okay. So I get these, and then I would have to add right, I think I was missing one. So N5 is still correct. N6 would actually need to be N4. I want to shift these up by what? Okay, what is where are they going? 8, 16. So I'd be multiplying by this number. So N6 will be N4 times, or N4 shifted up 16. Now N7 is going to be N6 plus N5. Okay, so now I should see no, that was not correct. try it. You'll be a trillionaire, but you're a joke online and your kids are ashamed of you. Okay. I don't know why trillionaire would not be in the dictionary by default. That's odd. I guess it's just not on Firefox. Firefox didn't think to add trillionaire. Oh wait, am I missing the C? Wait, what? Sorry, dog barking. Okay, so what mistake did I make? 16A8 is the right value. But then I want to add they're okay. They're okay. There's too many numbers I missed. I got lost. So where am I at? So N0 is the original value. N1 has been done that to it. N2 is now at the point where I have, if I mask it, which is what N3 should be. Or sorry, N4 should be the mask. So these are all the 10s combined at this point. So, I mean, I guess what I really mean to do is I actually don't want to shift them up now. Because if I shift them up, I would end up putting this 8 into... No, that's actually fine, because I want to bring this up and put it there. Okay, so... N5 needs to be the multiply, right? Yeah. And I guess I need to make sure it's masked as well. Because that might be what's throwing me off. N4 times 100. Make sure it's masked. Thanks for follow. Nobu Dev X. That's it. It's gotta be that. Okay, so I've got that set ready. Okay, I guess let me think about it. If I'm adding... No, this is fine. So then I would take this. I'd be taking it N4. Shift everything up. So these bits are now going to contain that section. And those bits are going to contain that section. So N6 should be N4 shifted up by 16. Make sure it's masked. That might be what threw me off. Okay, so now those ones are in place. And then I would add these two together. And I'll just keep making sure they're masked. Alright, so now I have 16C0, which is that bit, and then 37D. That's it. Okay. All right, now, if this is technically doing, if N7 is equivalent to doing 100 times N4 plus, this is 65536 times N4. I can combine these two together to get a 6 there. And now I can skip N5 and N7. So I just have N5 is equal to this. And to make sure we're masked, I'll do N5B. So now N7 and N5B should be the same value. Cool. So what step was N3? N3 was a shift down, and then N4 was a mask. Right? That's what those were. Okay, let me run through the steps. So N1, I think it was just N0 and maybe this is easier to see. And then N2 was actually just a really simple thing. N2 was just N1 times 266. And then N3 is this where it gets interesting already? Because now this is a division. Take N2 divide by 256, which would be the same as doing N1 times 256, or no, 266, and then doing divide by 256. What does that mean? What does that mean? Is it not just N1 times 10 then? I'm super confused now. Is this how the simplification happens? Okay, I'll just keep writing it out. N2 is doing a downshift, 256, and then N4 is a mask. Yeah, that's already looking suspicious. I think we're doing this, right? Because there's just these bits that need to kind of go away. And then at this point, I've determined n5 is equivalent to doing n4 times 65636. Am I crazy for thinking that N3B could just be four? Okay, let me think about it as being like 4x over 3. Okay, well, I guess that's actually where it drops out then, doesn't it? Because what's 256 or 266 over 256? Right. That's this value. So would I not then just be able to say can I just say N2B would be equal to N1 times that? Is there a way I can... Because that's really interesting, right? Is there a way I can make this still be integers after doing that? Can this be simplified? (133 over 128). So this could simplify down to multiply by 133, shift 128. Which shift 128 would be... Dog. Bro. Alright, I gotta take the dog out again. I'll be right back. I'm back. Yeah, I don't think it's wait, what is this? Quotient and remainder. 133 is equal to 1 times 128 plus 5y. Does that mean something? Is it possible to combine it like this? I think it may just not be possible. Because even here, that's kind of where they got stopped at. They have a mask, a multiply, and a shift, right? I guess kind of what I'm doing is I'm just rediscovering a different multiplication that probably works for not this little Indian thing that they're doing. So I guess that's what I have, right? So yeah, now I'll just start over, I guess. I'll just write these out. To be sure I'm still on the right track. I will write this, though, as just a shift. Yeah. Although this one might be interesting. Just check what we have. 3A16. Is that right? Did I mess up again? Where should things be? Oh, duh. I have to make sure this is still clipped, and then now it's gonna make sense. Okay. One 6C0, and then I would have 0370. So I'm at 5 operations. I'm just gonna go from here. So then the next thing that I would want to do is I'd want to essentially yeah, I'm gonna start just by taking this whole thing and shifting it down. Well, I guess I don't really have to shift it down quite yet. Oh, no, yeah, this would be a shift down at this point. So, shift everything down. 816. Yeah, I'm shifting everything down 16. So I should see a 37D there, and then I have this 16C0, which I want to multiply by something and then bring it all the way down to the bottom. And then I would have a final mask. Or perhaps I have to mask now. I'd be multiplying this by 10,000. That's what I would be doing. So yeah, anything that is... Yeah, so this is the result now, and those... Are those guaranteed to be zeros? Okay, let me try... This would be the largest value I should be able to have here at this point. So it'd be that. So I'm just going to see how that works. Okay, so it looks like... Is that lower digit always going to be a 0? I guess if I consider how a shift is working here... The next power of 2 below this would be like 1024. No, wait, how does that work? Okay, so, okay, well, either way, the highest number will come up 3. So, and then I have, I'm going to assume that these bits need to be clean. I mean, not necessarily, I guess. If these two don't overlap, I could probably skip an intermediate mask, possibly, and just use a shift and a mask at the end. So, I really wish that highlighting was a little more less stupid. A little less stupid. So, I would have this value is the maximum that can be there. And that would drive up 3 places. So from here, this maximum value would drive up to 3 places. 1, 2, 3, right? So I'd be on this bit. So yeah, I have to do a mask in between to clear that, because otherwise it's gonna be too messy. All right, so N7 is gonna be a mask of N6. So I need and then I need to clear so at this point this is what it should be. Hero1, what did poor JSON do? I'm writing a string to number thing, and I've seen some optimization that can basically collapse scanning 8 digits into as many math operations. So instead of doing like multiply by 10, add the value, increment, multiply by 10, add the value, increment, multiply by 10, add the value. So instead of doing like 3 operations per digit, I could take 8 digits and do 8 operations in essence and get the number from that. So if the number is 8 digits or longer, it would be preferable to parse them as such. Process them like that. Yep. Which is cool. I'm like rediscovering some stuff from here. Though this guy is insane and was like, let's talk about Little Indian alignment. Like, what do you mean? Literally, why? Why would your string of bytes in a row just suddenly flip around? I don't know. I think people who talk like this, who like get into math and then they just like jump to flipping things around and inverting them, are just crazy. I think it's just crazy. Especially related to a string. Your string is not going to be reversed. Your string is going to be in the same way. Crazy bit of string, yeah. And then also, if we're talking about programming, your program is written with no assumption for which byte order things are on the system. So, in order for this algorithm to work in any programming language, you have to go in there and manually flip all the bytes around. You have to reverse the bytes. Which is just silly. But I'm like I'm like figuring it out in the non-silly and normal programmer math way. How it would actually be written in real code and not like assuming you're, I mean, you're just crazy. Like, I don't know. Okay. So I've got N7, and then I technically know at this point that I would be able to do a single multiply and then a shift, and I would have the final result, effectively. So the idea here is that N8 will be equal to N7, and I need to multiply this by 10,000. So I get that high thing all the way up. And then I need to shift up those low bytes up 32, I guess, at this point. 8, 16, 24. Wait, what? Hang on. 8, 16, 24, 8. So, I gotta get right up on my computer to look at this. 8, 16, 24. Yeah, okay. So N9 would be N7 times, or shifted 32. And then I have N10 would be N8 plus N9, and then I just do this mask. So now the final number is in the top 8. Right? So then if I were to take the whole thing and shift it down, I guess this is 64. I meant 32. And that's okay. Try that again. And that would be the same number that I typed in. Okay. So now I know that N10 is equivalent N10B will be equivalent to doing N7 times, or 10,000 N7 plus, okay, whatever this one is, 2 to the power of 32. And 10 is equivalent to doing 10,000 N7s plus that number of N7s. So if I combine them, I would just find wherever 10,000 is. This would be 10,000, change that to a 7. And there's the number. And that should be the same as N10. Okay, I need to, because Python has infinite precision. They're equivalent. Okay. Let's get back up to the string. All right, so that's that. And then I've determined I need to do a shift. So N6 would be N5. Shift by 2 to the 16, which is at the same value. Yeah, it'd be 6, 5, 5, 3, 6. And then N7 would now be a mask. Let me write these as the left shift instead. The division is not actually more helpful because I can't collapse those like that. If there was a way to multiply an integer by a fractional integer and stay in integer math, that would be cool. But I think there's not. I think the only way to do that is just like this. The multiply and then the shift. So now at this point, N7 would be N6. Is it now this thing? So I've shifted it, and then I think... Do I need to mask first? I have to mask before I can multiply. I think that's the thing, right? N7 is, yep, I see it at the top. Okay. And now N8 would be N7 times that value. Which this is just a really big value. And then N9 would be a final shift down. So, does this look like what they've done? A mask, a multiply, a shift. A mask, a multiply, a shift. And then a mask, a multiply, a shift. Mask, multiply, shift. And then mask, multiply, shift. Cool. And I can count that as 9 operations. This guy counts that as 7 because he just can't count, I guess. I guess it's actually 9, right? If you add these two numbers together. Okay, well. I've rediscovered it. So I'll do this. I'll write this as a function. To int with a string. So the first thing to do is try to say, yeah, n will be int from bytes string 2 bytes. Is it just string to bytes? I'll find it up here somewhere. And from bytes string dot... Can I just write string dot 2 bytes? Okay, give me another window. I don't know what this is. Python string device. Encode. Dot encode. Sweet. Okay. Is there a way that I can, like, Python into 64? Can I just do this? Okay, so it's not a thing. I have to throw in a mask at each of these steps to emulate what a computer would actually do. I mean, I suppose I can actually ignore it because I'm actually running masks the whole way through, so I can actually ignore it for Python, can't I? Yeah, because as soon as I do this mask, I've cut off any of the high stuff that I don't want to have. And this really big number. Now, the thing is, the string does have to have, I mean, technically it doesn't have to have high bits. I could actually just do like 15 and I should get the same result back. Okay, it didn't happen. It didn't happen. So why not? Why not? Why did it not happen? I didn't mess up a multiply. Oh, I'm actually unable to write. Okay, now let's try 2 and 15. In fact, I will now just run a loop and compare this. So I will do for I in range a 2 to the 64. I guess I need to do -1. Oh no, it'll do that for me. So then I just say if I does not equal to int string of I, then I will do print I and break. 10,000 failed. 10,000 failed. Okay. Why did 10,000 fail? What does this look like? I see 10,000 there. Is this up to 710? Is that 10,000? That is 10,000. Okay, so a bit kind of showed up. Okay. So the problem happened on this final mask where I cut off. Okay, well, I mean, I guess I can step through and see exactly where it goes wrong. So I mean, I have the result. There's just this extra bit sitting there that kind of stuck around somehow. So I will do n will be int from bytes. Okay. So that's what this looks like. So the first step is this line. So now I've got 0, 0, 0, 0, 1. That seems right. I can do this. Okay, so what this has done is multiplied it should have added a thing together. So what I should get is basically 100 in if I okay, I'll go ahead and shift it and then I will. I think I see where this 1 has come from then. It kind of stuck around there and has stayed. Well, I guess this is the... No, because it worked for everything lower than that value, right? That was the very first value that it broke at. Okay, so we're actually still clean, I think. The implication here is that... yeah, so what has happened by this point? I don't know, it actually just still looks fine. It still looks fine. Though it does look like I did nothing, because it just stayed the same. Right. So I did a shift, and then I did a mask. Okay, so it still seems okay. What does this mean? What would have happened here? I group it up in tens. So this one actually should stay 1. Yeah, so the first iteration, it should stay as a 1, because it groups it up with... So the first 2 zeros are grouped, the second 2 zeros are grouped, and then a 1, and then technically a 0 gets grouped at this point. So I just have 0, 1. So then the next step would be this multiplication, which will group hundreds together. So it would basically group these zeros all together, and then this one with a bunch of zeros ahead of it. So it'd still be 0 at that point. So yeah, this is now this piece is now the 1 and a bunch of zeros in front of it grouped together. And it's still the same length. So it's still okay. I do this shift. And then I do the mask. And I should still just see a single 1 sitting in there, which I do. Okay, so now I think what's happened at this point is that Python kind of came in here, and because this multiply is just such a big value, it overran. So yeah, now I have this extra lone 1 sitting at the front when I should not have had a 1. And this encodes the 10,000. I think I had a 0. Yeah. So that encodes the 10,000, and that would come all the way down. Okay. So it's just that it's fine. The function just needs, it does need a mask at the last multiply. Which I guess I can just do this because this would technically be a free. Yeah, it should just be these, right? Because I've taken these and then I combine these two together. Well, I guess I kind of know. Okay, what's the largest? What's the length of this? So this is actually the lowest 7. The lowest 7 are actually part of it. And in fact, not even just the lowest 7, it's specifically that 5. So let me just make sure that this final mask is very exact on that. Well, actually, like, what's the highest value that can go there? If I know that that 1 is the highest value it can have, let's see, bin of 5. So is that bin 7? So it'd be 7 followed by 1, 2, 3, 4, 5, 6 Fs. Okay, now let's run through that loop and see that everything works. We're running the CPU. How long will this take? I'm just running this to prove that it's correct for any input, which is taking a long time. But I can stop it to see what number I got up to. Alright, I'll actually just stop it there and see what number I got up to. What is I? What is I over 2 to the power of 64 minus 1? Okay, so I didn't even get a fraction of the way through the numbers. But I think this is certainly correct, I think. So, all right. This must be a correct algorithm. So now the only issue is I need to interpret those string bytes as that. And because of how it works, I could actually... Okay, so I guess there's like a minimum value before it becomes better to do that, right? So if every digit requires... I could also do it in like terms of twos as well, because this can basically go up from like parsing a single digit like this to parsing 2 digits to 3 digits, which would be a 2 and a 1 digit. 4 would be basically, I think, this step. And then, or I guess it would be this step. And then 5 would be this plus a 1. All the way up to 8. And 8 would be kind of the limit. Yeah, because essentially I take these numbers and I throw them up here in this area, and then I have to bring them back down. Okay. Let me try writing this out and just doing like a speed comparison, I guess. So n will be 0. I can do 4 C in I'm gonna assume the bytes are actually gonna, I'm assuming these are actually gonna come in as bytes, because that is how I will be processing them. Say B string. N times 10 plus B. And then I can return N. Let me just make sure this works. Right, I have to do N minus 40. I'll write it out as a mask. Because technically that's all I have to do. No, I still have it wrong. Gosh. All right, so there's how that one goes, and I will update the other function to just accept this as bytes. So B string and from bytes. I guess I'll include that. I feel like it's probably not that much worse. Also, because of how Python works, this might even be slower just because I have more lines there. I'm not sure. Okay, so I'm going to make an array of like, what number did I get up to? I'll make an array of 1,000,000 numbers, random numbers. So I have a B string array and then an result array, which this will then be filled with, I think random can just give you an array of numbers. That's pretty bad. That's pretty bad. That's pretty... Can I not get a range? Okay. I would like to not have a range in there, because a range is kind of insane. Sequences generate a random permutation pick distribution. I could swear that this can just, like, you can say, hey, give me a random thing, and it'll just go. Return random integer, including both endpoints. The issue is going to be, like, producing this list of information. These lists. Returns a k-size list of population elements. Okay, let me just see if it's, like, slow for a very large number then, I guess. Random choices, range. Let's just see. I would like 1 million elements in the range of I guess the biggest number would be 8 digits. It would be 1, 2, 3, 4, 1, 2, 3, 4. I don't know what that, I don't really care what that number is. All right, what do you think about that? Wow, that was quick. Okay, so, all right. So B string array, dog. No. No. Nope. Nope. It's time for lunch, isn't it? Rhett, you're right. You're right, buddy. Dang it. All right. Well, that was really fast. Alright, I'm just gonna let this run while I go get food, because I'm sure that's gonna take a while. It's done instantly? This is 1,000,000 byte strings? Okay, give me a slice of 2 well, those are all random numbers. Okay. All right. That was really fast. So I guess I'll just write the test out then, because this is perfect. So run test. So I give it the function that I want it to run on. And I guess I give it the result list. I need to import time. What do I need? Yeah, I need the function, and then I need this list, and then the result list. So do start equals time dot time. What is it? Time dot time. Great, okay. RPG Maker is shutting down its forum? Why? Are they just moving to Steam forums? Alright, the third time I'm running this function definition. The function, this list, the result list, and then I would do start time dot time. Then I will do n is equal to function bstring list I. And then the comparison might be kind of extra. I'll just run it again and I'll skip the comparison. Print I and return. And then end this time.time. And then I will do print elapsed string of end minus start. Run test of toInt with bstring array and result array. Half a second. toInt plain. Yeah. I mean, there it is. There it is. That was certainly faster on Python. That's kind of funny. I think it is because I have extra lines. I think that's my guess. Python being interpreted, it goes line by line. When I type in def, it doesn't actually do like any kind of pre-compile there. So at least in Python, it was definitely faster to just not the line count probably affected it. All right, I'm gonna go get lunch. I'll be back with food. Yeah. I guess I could also just go and write it in Rust and see which one of these is faster. Okay, I'll be back. Oh, sorry, I should probably read this. Will there be an archive or backup of the forum? And no, there are currently no plans to provide a public archive or backup of the current forum as soon as it's closed. Moving to a new forum with zero backup to the old. So they're just, so it's just they're moving it. Okay, I'll be back. I have used the forums before for stuff, and there is a lot of stuff on there, and it is actually really active. But usually everything that's on there is also reposted to a Steam. And is already on GitHub as well. So it won't be like losing anything if they were to just wipe it. All right, I'll be back. I am back. All the text is just not rendering. So dumb. I just literally forgot to load the text. All right. So yeah, okay, first of all, the speed of this is already kind of crazy, but I am suspicious that the original function just has too many lines in it. So I'm going to merge these down. And also I'm going to change kind of just like how the whole thing runs, or the sample. I'm going to make all the samples be hang on. Just going to keep going, doing this, putting it all in one line. Where did this slash come from? Oh man. Let me try to bring this down a few. Does this thing... I'm just gonna close that. It may even just be that the way that Python represents numbers may just not be very conducive to this kind of code. Like, yeah, like, what is that weird thing that's happening? Three closes. And then 3 more closes. Okay. But I am sure that it might even be that I could just run these all in a row, and it might be fine. Let's run. Okay. So the validation is still in there. So I wrote it right. So yeah, it may just be that the language just isn't good for it, right? Because the normal loop is still just way, way faster. Hey, Professor Logout. Okay, I'm gonna eat. And then the next thing is I'm just gonna write this into Rust and run the test there, where I don't have to worry about Python's bigger integers. Which I feel like that's probably what's happening. Because these are kind of guaranteed to never overflow and need a bigger number. And this one kind of quickly overflows, or definitely overflows here, and requires a bigger number than 64 bits can support, which may, that single thing may just be what's slowing it, what's making it be slower. And if a hundredth of a second, or 200ths of a second, actually there's more like 100th. I'll run the test a few more times. So yeah, it may still be that the line changes made it slightly faster, but it seems like it still didn't. So, okay. I'm eating. And then I'll write it in Rust. Oh yeah. And I forgot the test data. I need to change the range so the range is always 8 digits. What am I up to? A string to number parser. So I gave it a string that's like some number as a string, and then it will provide just the number back. It seems like in Python, I need to change the test data so that everything is at least 8 digits, or everything is exactly 8 digits. Because right now it's just that could make up for that. It could also be the overflow really slowing it down, because then it has to probably do like a conversion to a different numeric type. Eating chicken sandwich with barbecue sauce, Swiss cheese, onions, pickles, lettuce, mayo. No, the only thing that's warm is the bread. I toast the bread. But I have to feed my dog and I take him out. So that adds like 5 minutes. Sounds delicious. It is. Really getting intermittent fasting. I don't think I could ever. I gotta eat 3 times a day. Mm. 1 month on, 1 month off. Yeah. Are you doing it to lose weight, or is there a different reason you're doing it? Was he chatting at the time? No, that guy, I recognized him. That was like the first time he had written in chat, I think, for a long time. But I did recognize his name, so I might have talked a few times. But no. Yeah, he said he was just like lurking a lot. Wait, I kind of forgot how numbers work. Even though the range is like 0 to 10,000, and not 10,000. Even though the range is 0 to 10 million. Sorry, 999 million. 99 million. That doesn't mean there's an equal distribution of like short numbers. Half the numbers are still going to be 8 digits long. Losing weight was the original start. Yeah. No. Well, I haven't weighed myself in a bit, but I know that pretty much every time I do, I'm lighter than I should be. My BMI would always be categorized as like very underweight. But I do have a lot of muscle mass. So even though I'm light, I'm incredibly low fat percentage. How tall are you? 5. Let's check the ID. 5.7. That is, I don't know what. I should probably remember this for what is it? Yeah, I don't even know how to write that. Okay. 5 times 12 plus 7. 67. 67 times 2.54. 170. 65 at my chunkiest. Still too much fat. Mass. I don't need kilogram to gram. I want pound. Yeah. I'm in the 50s. Last time I measured, I'm in the 50s. I was, yeah, it was, there's a time that I was eating a lot. I was working out like daily in the morning. And I was getting my weight up, and like 120 something. It was probably like 125 was probably like the highest number that I ever read on my weight. I'm sure I'm lighter than that now. All right, I gotta put my plate away. Americans in there, yeah. Yeah, I had to. 170. In the 50s, low 50s. I don't weigh that, I lost that much. Dang. Well, that's pretty good. All right, I'll be right back. Putting my plate away. I'm back. Lost a whole person. Yep. That's a lot. Still want to see and feel the difference. It's very nice. Okay. Now I feel like it really is just this. This multiplication here does it. I'm going to do this though and make sure that I am still at, this is the first number that is 8 digits, so 1, 2, 3, 1, 2, 3, 4, to that range. Okay. And since it takes half a second, I can multiply by 10 and go to 5 seconds. Get even more just timing, possibly. I'll do 4 million. That one was quite a bit slower. All right. And then to produce this array, okay. Run test to int. 2 seconds. That's crazy. I mean, it's also possible that the masks and the shifts and this specific multiplication just are not optimized for Python. These are probably just like really slow operations. That's my hope. Though it does suck that I can't even see if this is better in Python or not. Okay, parse number. So I'm just gonna start with this being an no, let's go to tests, and I'll just write a test here. So how does this work? I need to do test. Well, actually, shouldn't it be like benchmarks? How do I do that? Very big enough on this. All right. The bench attribute is currently unstable and only available on the nightly channel. Okay. So I guess I just do timing myself. Time. Standard time, core time. Standard time. Whoa. Instant now. That looks super JavaScript. Java. Not JavaScript, Java. Right, Java is instant. Instant now returns what? Do I need to import this? No. Compare number parse. So I will do %plain. Do I write it this way? Wait, is this how I write it? Nick Afton. Afton's the Five Nights at Freddy's guy. Right? So parse into plane. I take in a bytes, which is a reference to U8. And then there's Rust. I don't want that. What is this? U64 from B bytes? You say from B bytes? What is any? From? U64 from? U64 from when starting from a slice instead of an array. Crazy how ancient China found this out. What? This is Instagram. I mean, China figured out something posted to Instagram. Lunchtime's over. Lunchtime's over. Fun time is over. From BE bytes. I have to do this. But what if I knew for a fact there were 8? What if I knew for a fact there were 8? Because what I saw them do is they did like a pointer thing. I want to see this. They do something with the pointer. Try parse. Oh, no, they just run it. Okay. Yeah, they just use... Wait, from LE? From LE? Fun Please says fun time is over. Yes. There's just from LE, from BE. Why are there thumbs down? It converts an integer from big Indian to the target's Indian. On big Indian, this is a no-op. Well, yeah. Okay. Target endian. Config target endian. Ooh. So I suppose if I know that I might be on different ones, I can write two different sets for it, if it turns out to be faster. So there is from ASCII nightly. Okay. Plain from string or string parse can be used. You know, let me see what from string radix is. Ken is losing so bad players look like a bunch of zoomers. I don't know what that means in terms of... I just don't know what that means, actually. Self from ASCII radix. That's where I am right now. Just search it. Okay, they can't literally be it. Nothing's wrong, Professor Logout. This can't be it. This can't be it. Bosnia faking a foul. Isn't that normal? Oh, here it is. Is signed. 0 is greater than the... Oh, if this type is signed. Match source. If it's only a positive or negative, it's bad. If it's positive with stuff and a negative with stuff. And then if it's signed, we say false. Otherwise, it's going to be true. Okay. Unwrap or PIE. And not overflow. What? Run checked loop while let C and digits. Multiply is the is result check to multiply radix. X is unwrap C to digit radix. Invalid digit. Result is multiply. And then result is result plus the digit. And then we set digits to be the rest. Okay, so it's really simple. He reads 1 byte, 1 character at a time, multiplies the working value by the radix, and then adds that character as a digit to the value. Okay, so they've actually... this is like the craziest way to write it, but that's what this does. Alright, I just want to see what Rust does, and that's what Rust does, and that's pretty good. That's fine. I want to see if they did anything clever. In fact, let me do parseInt Rust. I'll have a test that will I will also time Rust internal. parseInt this. Okay, so parseInt plain. So I will do can I write it like this? No. For b in bytes. I'm really trying to write Python here. I would do n equals I will actually just unroll the loop. So in fact, yeah, I'll just fully unroll. Well, I mean, it's technically going to compile it. I'll assume it's always going to be 8. I'll give it the best case scenario. In fact, I don't know, maybe I should test it. I'll just write it generically. And then if I'm suspicious that it should be performing better if every input was definitely 8, then I'll try that. Guess what's the problem here? Expected U64, found U8. So I guess the problem is that this byte is here. I can just write that. Parse into Rust. I guess I just do U64 from string radix bytes 10. Yes, you're complaining about it being bytes. How about this? Rust. Byte string to end. How about that? Yes, not getting it. It's from UTF-8. I mean, I kind of don't like that, though. All right, let's just say this. Technically, I can actually get them as bytes, so I'll leave these all as like a string input. Just because that's what this one wants. So I'll give it that. And why are you still upset? Oh, I'll just say unwrap, which will panic by default. Yeah. Play some ASMR Bible reading. Is there a way that I can get this without, like, the fastest way I can pull this out? Okay, so everything needs to come out as this, so I'm going to I think I can just write this. Wait, is it actually going to let me write that? Interesting. Parse int new. This needs to be input as a string slice. Let me just see. It's really letting me write that? The question mark? I feel like it's not correct, though. But alright. So I should just have time. Instant now. What is an instant now? Yeah. So say start rust and rust. Okay. I need to produce the test data. So Yeah, I'll do like 10. I'll do 10 million. I'm going to assume that they are just correct. I'm not going to run a check to see if they're right. I'm just going to assume that they're right. Because I guess the idea is that if they are perfect, if they are correct, what would be their best times? So now I will copy in this whole string. There we go. Yeah. Okay, so I am going to need random. It's already actually here. I want to go to I'm not a bot. Okay. Learn Rust. Read the book. Guessing game. Rand RNG. Okay, it seems like it's just okay with that. Huh. Okay. So rand, thread rand, gen range. I guess let me look at this. Um, so I would like. That was probably it's probably fine. Actually, what's the largest number? Because if there are 8 digits, $32. What am I doing? It's going to be like a vec of U32. Additional. I want to reserve exactly 4 million numbers. And of course, it needs to be mutable. I guess I can do const. Is that how this works? Yeah. Actually, it would be like iterator. Wait, how does this work? Yeah, how do I write a for loop like that? I forgot. So many tabs. Rust. This. I know it's here somewhere. This. I use this. Okay, what is I? I is unknown. What does reverse do then? Oh, what's going on? What is this? Say 0. Ah, okay. Sure. Numbers I will be equal to it's random range. Is it because I have like a problem here? Okay, cool. Now it's giving me stuff. Dev dependencies. Dev dependencies. Okay. Rand 10 0 10 1. Okay, it's happy now. Sure. And these are not, duration does not implement display. Okay. So what can I do with you? Duration. As seconds float 64. Cool. Numbers reserve. Use binding numbers isn't initialized. Use that. What? Okay. Interesting. All right, so I've got all the numbers. And then I'm going to get all the strings. Number to string. Oh, I can just use format. I can format. This is I don't know, it might be a little bit extreme, but I know that this will work. Okay. So then the idea is I will now loop through every single one of these. So I will write a macro. Run test. I provide the function. which I think is going to be an identifier, right? For S in strings. Okay, I'll actually run the assert equals. We'll assert equal that the function with strings I is equivalent to the numbers of I. Okay. Run test. Percent rust. Why you unhappy? Expected string slice found string. And you're okay with that. All right, cool. Percent plain. Run test. Percent new. Okay. And I'm going to exclude that test for now. Could not compile due to one error. What's the error? Ah, right. I guess I just say or else. Follows op if the result is 0, otherwise. Okay. I'm looking for where the jeez. Looking for result. Those turns the okay value, but I want the thing. Or provide a default unwrap or okay. Okay. That's how it is. Unwrap or 0. Now we're happy. The deal of the century? What? Wait, what happened? Index out of bounds, the length is 0, but the index is 0 on this line. Line 39. Is equal to the new length. Okay, yeah, just resize. No, just do reserve and then I'll just use push. That's probably how it's meant to be written. I'll buy one. Okay, so plain was slightly slower than Rust. All right, let's jump up to 8 million since I was so fast. That was less than a half a second. AliExpress.com item. Should I even open it? Okay, so it's good to see that Rust is faster than what my simple thing. Okay. All right. That's always good to see. Now the question is, unused variable I. Well then, you want me to just underscore that? You do. Okay. All right. Okay. Now I guess the question is, let me do print line. Let me do a print at the start before it runs. Print the sample of the test. I could probably have to do that. And then I'll do strings. Let's go for count over 2. What do we think about this? What a stupid error. Okay, run test. Get a sample of 10 numbers. Cool. That's 10. They're all 8 digits. Oh wait, actually no, a tenth of them would be shorter. But yeah, I'm gonna assume that the range is correct. I'm gonna put an underscore so I can see. Okay. I found a 170 centimeter Renamon plushie. Okay. That's very large. All right. Now for this. So I would say input as bytes, and then it would be U64 from big Indian bytes as bytes. And then you're like, you want a reference, right? So we just take a reference. Just take a reference. All right, so the issue here is that it's not the right size. But I'd like to somehow make it be all right with that. Input split at try into multiple conversion APIs can be used. So, okay, I want to see what they do, because they do something here that I think is probably a required optimization from this, which is this peak 64, peak U64. So let me try to find that. I guess it's this one. Okay, I'm looking for peak many unchecked. Unsafe implementation. I guess it's here. Unsafe, read unaligned, as pointer. As pointer. Pointer the first byte of the string slice. Okay. So I want to use this. I want to say let this has to be U64 will be equal to input as const read unaligned U64. If I have a stand pointer, I guess. Okay. All right, let me just do print line. Run that. I'm gonna skip these. Run that. Yeah, so I'll just see what this does. What I get out of this. If I get the the correct result. Okay. All right, so let's do X of this. 31. Oh. It's backwards. It's backwards. Interesting. Well, it's backwards. Why is it backwards? Is the read unaligned just reads it as Little Indian? Is that how this works? This is assuming we're getting that. Okay, let me see what pointer is then. What's up with this bit though? Do I really need that bit? I guess I just say underscore, then it kind of figures it out. Okay. This is weird. Because I know that the byte array is not like that. I know the byte array is not like that. So it's read in the bytes, and I think it might be... Oh, it is backwards. Oh, no, yeah, it is backwards. Because number 1 would be a bunch of zeros and a 1. So... Wait, no, wait. No, why is it backwards then? Why is it backwards? The bytes should still, like, the smallest digit should still be at the end. I need to understand why that happens. And if I can tell it to do something different. Where's the functions? Okay, I need to know. The issue is that, like, x86 x84 is Little Indian. Um, hmm. U64 from... I mean, let me just try this then. Let's try into. Does it just, like, go for it? Okay. From this. Yeah, here, okay. Seven, 9, 1, 9, 3, 1, 2, 2. Great, okay. So, I'm gonna use that, because this is, like, technically more safe, I guess. But I don't know, maybe the try into is too bad. I guess I could actually do from BE, which takes a U64. But let me try this. Let me try this combination. The assumption is that this will be written as big endian. Big. Or little, I mean. And then it will load it correctly. The thing that's confusing to me is that it still has that section selected. It's just not... It's so weird. The numbers changed, but it like still pretends like I have the same thing selected. Okay, it's the wrong way around. From B. On big endian, this is no op. On little, the bytes are swapped. A no op. Great, that's what I would like. Though it does seem weird that I have to say from B instead of being like, you know, from LE, which is kind of the direction I think that would make sense in. Three, 4, 1, 0, 6, 8, 3, 5. Okay. All right, I've got something that I am okay with. I'm okay with this because I really want it to be in the format that I want it to be in. So then all I have to do is run all of these, and I will just trust that I will trust compilation to make it a little smoother. I can probably do this though, right? Now it is unsigned. Do they have the triple? They don't use the triple. Okay. And then I'd be doing this. Six, 5, 6, 3, 6. 16. Multiply by this. And then this would be N shift 32. I'll just write it all out. Okay, that doesn't have the right things. Mask time shift, mask time shift, mask time shift. Okay, and it is doing validation. So I guess I'll run the full test. And hopefully it doesn't brick. And it bricked. Okay. Attempt to multiply with overflow. Right, so this one can overflow. So I want to do wrapping. Okay, so what does wrapping mean? Because I want the multiplication to be that it carrying. I guess I'll just search. Rust. I want to multiply and specifically just ignore them. To ignore, result is so they're saying that wrap is that even a real thing? Overflowing multiply? Tuple of the multiplication along with a boolean indicating whether an arithmetic overflow would occur. Then the wrapped value is returned. Okay, so wrapping multiply is what I would do. That's the only step that can overflow. Attempt to multiply with overflow. What do you mean? Could this one overflow? Well, what line? Line 22 overflowed. Multiplying by that overflowed instantly? That overflowed instantly? Oh, I guess these two can. Okay. This one... Okay, no, I think they all can. All right. I guess they all can. Whoa! That is way faster. Okay. And it was correct every time. That is way faster. Alright, so now here's the question. What if instead I did any range of numbers? And then I'm going to make sure that I left pad with zeros. So... Well, okay, I guess I can't. I guess I actually can't. Alright, so I just know that this one works definitely because of this. Okay, since I'm suspicious of it, I'm going to I'm gonna make it so that this will Okay, well, if I know that it's always faster for 8, so it's kind of like the question is, do I have 8? Yes, okay, then I do this set and I have a number. And then it's to ask, do I have 8? And then it's no, and then the question would be, all right, do I have 4? And I'd say yes, so then I would run that with 4. And then it'll be, do I have 4? And if not, or I guess the next question would then be, do I have 2? And maybe it's a yes or a no. And I'd be like, do I have 1? So essentially making sure that every step of the way that I'm going through an integer, I try to run this. This is way faster. And it's not even very cryptic. I guess it kind of looks cryptic, but it's not really that cryptic. The unsafe is a bit annoying. And if I know that it is in Little Indian, which means everything's going to be flipped backwards, then... I mean, either way, I think this is better. Even with it doing a swap, it's better than nothing. And it's really short. And I don't need a crazy big library. I haven't looked at this one yet. So now that I've looked at that and find something crazy, let me look at this one. Parse float. This does self parse float partial. Parses parse float. Parse float. Match parse number. And then rest. Oh, as we try to parse that as an infinite or an add. I'm gonna try fast path. Okay. Number. Power tens. Fast path. Oh, look at that. Mask, multiply 1, multiply 2. They do the subtraction. They do that and a wrapping multiply. Shift. Mask, wrapping multiply. They do just have the unnecessary step at the start. They're doing the subtraction. I think it's just kind of stupid. Because I know I'm parsing digits 0 through 9. So subtraction can just be blended into the mask. They also start with a multiply by 10 and then a shift, which could have been combined into a multiply by 256. So I guess that's with the assumption that wrapping multiply is slower than doing a multiply and an add and a shift. I want to see what wrapping multiply does. What's wrapping multiply? My game is progressing nicely. Sure. What is this? What? Wait, what is this? Source num. Interesting. 1-to-1. Even the comment will not overflow fits in 63 bits is shared. Huh. Continue to go outside. Do you want to go outside? I'm taking the dog out. I'll be back. You just shut my monitor off. Okay. I'll be back. I'm back. Okay, I want to see... I want to see the differences in time between this like big Indian conversion and what else? Wait. And doing this one. I want to see what the difference between these two is. I would think this is going to be way faster because it skips a lot of stuff. But I wonder if it's going to be that much worse. Why is it not keeping the test results? Why does it clear the console every time? I don't want you to clear the console. Okay. One second. Okay. So I was like seeing 0.29 to 0.2332 is I think what I saw. So I'll run this the other way. Okay, 0.25 that time. .26, 0.24, 27. Why did I get 3? Okay, so that's just way faster, apparently. And then this is way slower. Even though they're doing the same thing for me. That is actually like substantial. That's actually a 100 millisecond difference, a consistent 100 millisecond difference doing this unsafe thing. Okay. Well. There it is. That is just actually way faster. I was consistently like over 3 that time, and this is like really close to full 10 millisecond reduction. 100 millisecond reduction. Thinking in tenths. Okay, well that's like, I mean that's just way better. So run the full test. Yeah. It's a great improvement. I guess this comment should go away. Because they can all overflow. I just want wrapping to basically ignore it. I want to see what wrapping, yeah, I want to see what wrapping multiply does. What does that do? It's really funny to see this just in Rust source code. Okay, seriously, what is wrapping? Yeah, that's cool. Is it here in compiler build-ins? Something called wrapping. Int macros. Intrinsics. Did I see intrinsics? Symbol wrapping. Huh. Okay. Whoops. Oh, wait. I saw. I didn't mean to click that. I saw intrinsics. So this is literally just interpret. Yeah, this is literally just that goes straight to compiler. Is what it looks like to me. It's not an implementation. Okay. I was just wondering if I was like paying for any function calls or something like that, but no, this is definitely this goes straight to like a machine instruction. Try into. I'm kind of interested to know that one though. To see how it does that. A U8 array to a U8 set of that. All right. Yeah, I'll just make these macros, I guess. So the first thing is to find I mean, I guess I need to like follow the number validation thing first. Because I still have to walk around other bytes. So yeah, first thing, check if we're seeing a negative. If I see a negative, then I'll say that this is a negative. If it is negative, skip that. If I is greater than the size, then we failed. Okay, that's handled. And now, now I'm looking for, yeah, now I'm looking to see how many digits do I have until I don't have a digit anymore. And whoops, and I think essentially what I'm going to do is I'm just going to track the chunks. So I'm just going to say, we have negative, this range is the integer part, this range is the fractional part, this range is the exponent, and the exponent is negative. I want to do all that. So I'm just going to copy this. So match bytes I. If it is 0, I wonder if I should just say it's 0. I'll just do this. I plus equals 1. Full part will be equal to bytes I. I want a range. Yeah, I want to get it like that. Okay. So at the end of this, whole part would be equal to I think it's actually start to I, right? So I'm going to save the whole part. I know that they're all digits. Actually, this doesn't need to be mutable, because I can just keep writing over it. So start I plus equals 1. And it'll be done, so it'd be from I to I plus 1. And this is the same thing. As long as it is that, we check the next one. Once it's greater, we stop. Oh no, this would be the loop. If it's greater than we stop. Then while it's not, we do this and we keep going. Okay, so that's the whole part. Saved. At this point, if I is greater than size, I guess I would have a method that's like string to int. Because I like a generic method that will do this. Also, you know what? Here's the thing. If okay, there's like two parts to this. I would like to not do anything until I know it's a valid number. But also, I am looking at every single byte individually. So would it just be faster to parse it in place? Because of this validation step that's running at the front. It's like if I know for a fact that I have to check each character, I guess the difference here is between doing like 20 comparisons and then doing 8 comparisons and then 7 instructions to compress that to an integer versus 7 comparisons plus 3 operations per. I guess it will always be faster to just have a generic function that can extract what I'm sure is going to be an ASCII integer. One sec. Yeah, I'll just be back in a minute. I'm back. So yes, definitely. Alright, so the next thing is to check if I'm out of stuff. So if I is greater than or equal to size, then I would be returning the size is how many things to skip that I return. This. So this should be some yeah, I'll say like parse int. Parse int whole parts as float 64. And then I. Is that what it would be? So if I read in 1, 9, I would be 0, 1, 2. So I say to skip 2, so next would be +2 - 1. Yep. I'll just have it always return to U64, I think. Or could I have it... I guess it kind of depends. I take in a string, I do... So I think what I do is I check the length of this, and depending on the length of it... No, there's something special here where it's exactly so many things are open. Close, close. Why is all of that open? They have this. So I can say I can have this rest thing. So I can do split at size of. So I can check the length of it, so that I know what I can split it. And then, yeah. And also, I guess I should do a test just to be sure that it definitely is faster, because part of this is now doing validation. And it may be the fact that just until I get to like a really large number, it's always going to be faster just calculate it during the validation. It could be a thing. Yeah, just do U64. So I obtain the size, and then I do They have while. While, I think, is not a real... While loops evaluate to unit type, right. There was this... I think I'm done with that. Input split at. I take a mutable reference to a reference. I mean, I'm assuming this is probably... It's weird. It's weird. Let me just try writing input split at. I should probably make this larger, right? Maybe. Let me do this. I should have set this up a while ago, but I never quite. Okay. Go up to 18. There we go. So while the size is greater than 8, I don't want to do a let. I would rather say remaining. Oh, what did I see? They had wait, let me go, let me look at exactly what they have here, because this is probably gonna be better. Try parse 8 digits, try parse digits. If let sum. Okay, so mutable reference means I am modifying the value that I've provided. So maybe it's not. No, I think is it? Keep going back here. Split at size of view 64. It returns 2 references. Okay. Yes, this returns a reference to 2 things. So I will have try into unwrap. Remaining will be okay. Good. Divides one slice into 2 at an index. First connect all slices from 0 to mid, excluding mid itself, saying will be mid to the length. Excluding mid. Yeah, of course. Panics. If mid is greater than length. Okay, so I'll be sure about that. And then I would do size. Size minus 8. Yeah. Subtract 8 from size. And then I would parse 8 digits here at this point. Okay, well, not quite yet. So this would be yeah, this would be to do this. Can I just say bytes then? I don't know, because the thing is, like, part of it is that you write this, but then I wonder, does that change how this works? Expected mutable reference. So I just say Found option F64. That's supposed to be returned. And then what? Parse, whoops. Parse int is returning. What's your deal? Parse int is returning a U64. And this returns F64 in usize. I'm so confused. This is just crazy. Okay. I just won't do that and just give it normally. And this can just go away. Because I just create a new reference to it. And then we're fine. It's all about the name anyway. Okay. Big Indian. Copy that. Paste it all. And this would be to do result will be should I do wrapping? I mean, I guess honestly what I should do is just because there's a point at which I could get such a large number that I would have to switch over to a floating point number. So I'll say this can return a float 64. This returns a float 64. And this will be a float 64. Because either way, I'm going to have to interpret it that way no matter what. So I may as well just make it easier for myself. So result will be equal to n plus result times 1 million. Is that right? No, because I would have made two groups like this. So I'm actually doing that. So every time I run this, I am parsing in 4 digits, 8 digits. And yeah, that's the same thing they do. They do this wrapping. I don't need a wrapping multiply. I don't need that. I do not have to worry about overflows. Well, I guess I actually do. Because what's the largest? how to search for this. Largest. I'm pretty sure it's not 308. Pretty sure it's not 308. There's a site that will do this. Turn on everything. That's a nan. Okay. Turn that one off. E0. What? Huh? Wait, I'm so confused. Negative 308. Oh, this is a very small number. I'm confused. Because I'm pretty sure this is just like extra stuff, and then exponent is like not that. No, I'm really confused. Also, these are floats. These are not doubles. Okay, never mind. Am I, like... What am I missing? What is this? So why is it that I type double precision and it's just only single precision float? Here we go. Did I have this? Okay, it is 308. All right. I mean, I guess the question is like, how do I deal with this? When a number actually gets really, really large. You know, maybe I'd just say if it doesn't fit. Oh well. Alright, here's what I'll say. I put the number into a floating representation. If if I fail to, if this multiplication overflows, then or I guess in fact it would probably be better just run at the start as like a check. If result is greater than some value, then I can guarantee that it's going to overflow after multiplying by that. So yeah, after multiplying by that and adding the smallest value, so I'm like, yeah, I can guarantee that an overflow. Well, because ultimately what I want to do is I want to maintain the accuracy of the first digits, but then keep the exponent. Because there's like, and maybe this isn't important to really worry about, but it's possible I could have a very, very long set of numbers, and then I have an exponent that is essentially to move the decimal all the way to the front. So now I actually have the front part that I have as the highest accuracy possible, and I can just throw that straight into a float. Otherwise, if I do it this way, if I allow wrapping, the value changes. If I allow saturation, the value will clip. I'm sure it's probably also fair to just say, if I start to overflow, I just call it infinity and leave it there. Because in fact, I think it's probably what these will do. That's probably what these end up doing. So we read a negative. We try to parse digits. Many digits false. Really confused by this setup. What would I want to happen? What about that? I mean, I'm trying to see what happens when they get too many numbers. This just runs try-parse digits straight into it. So they just... Overflows to be handled later, so they just start wrapping. So this point they check end digits, or they obtain end digits. And they get a number of dots, and they add how many they read there. If somehow nothing was read, return none. If we read fewer than 19 digits, we can just return it as it is. If we read more than that, subtract 19. If digits start, they say start over, digits start. Digits start as S. Okay, and that's a let. So we just copy it in. If it's a 0 or a dot, number of digits subtract. Whoa. Well, we have a 0 or a dot. We're counting how many digits are 0. Subtract 0 minus 1. Okay. What? There's no wrapping multiply for this? Okay. Fine. Back to U64. Wrapping multiply. Wrapping add. Okay. And then I suppose the issue here is that if I've read more than so many digits, I can be sure that it's greater than the maximum value. Okay. So 19 digits, I can be safe. More than 19, I need to check for an overflow. I can be, yeah, I can be sure that it did not overflow here. If I've read more than this many digits, I guess the idea is instead I would just parse out the first 20, I suppose, and then I would multiply that by how many were left as an exponent. These first ones, and then I will raise that to, so I can exponent, the exponential. No. Ten to what's the problem? Unstable feature. Float 64 power, okay. Okay, 10. What is happening? What did I just do? Found tuple usize usize. No. You did not. I'm so confused. Missing a comma. No, it's not. Okay. Should it be 9? Because it should be at least 1, right? Yeah, because they just could be 20. So I'm going to do times 10 to the power of that. Only parse first 19, then multiply them in an exponent of n digits. Okay. Okay. Good. That is handled now. If I read in a decimal. Now I'm reading in fraction part. So do start as at I. Whoa. I'm guaranteed to have a whole part. I am not guaranteed to have a fraction part. Actually, if I give a decimal, I'm guaranteed to have a fraction part. So I think what I do is the fractional part. I guess the fractional part is just going to be the same exact way. I can parse out a U64, and anything beyond that is well, it's a bit unique. Because I can skip zeros and still maintain a precision value. Because in theory, I could write out 300 zeros and then follow it with like 1, 2, 3, 4, 5, and that can actually be represented by a float 64. So it's kind of like I have a leading exponent. Okay, so I guess I'll just figure out how this is going to work. So I don't have a start here. I would have a start here just before this run. This would just be a none. And then it's probably going to be mad about me writing start equals this. Yep. Just run that again. I guess I'll just write this. Well, I guess that's only necessary if I'm going to use it. Because if I write it like this, then, you know, maybe it's a little bit better. I want to obtain leading zeros. Basically, the first non-zero I find is going to be the same way. I'm going to write that down as a fraction exponent, and then I would parse out up to 19 digits, and then everything else I can just ignore. Let's start usize I. Actually, I'm not going to write start there. I can have up to like 300. Yeah, the question is how many zeros here can I read before I guess it's actually just unlimited. I am actually just reading unlimited zeros. So I'll make it a U size. I will not make it a U size. We'll make it a U64. Basically, if it's 0, if the first digit is not a 0, the exponent would be 0, so it'd be like this number. Shift the decimal. I guess the idea is if I have 1 0, I need to technically take that number that I calculate and shift it back 1, right? So by taking the 0 and moving it forward. I'm just counting the number of zeros, I think, is all I'm doing. Size greater than or equal to size. It could also be, I am also doing validation at the same time, so I need to make sure that if the next thing I read is not actually a digit, then that is an error. That is an error. So I'll just write it like this. I will count leading zeros at this point. So while bytes I is equal to 0, I would do I add 1, bracket exponent, add 1. Okay, so I'm counting all these up. And then I would... Do I need to skip forward? I don't want to skip forward here, right? Well, I'm not sure. Do I? Make that back. So this one I know for a fact that I is pointing to a digit that is not 0. Or we could be at the end. That's also a break. So at this point, I have the number of leading zeros. What is this? Nothing. I have the number of leading zeros. Start is equal to I. I mean, actually, if I hit... No, I may not. I have to... I need to have a value out here that represents the fraction part. Which, I don't know. I don't know. I guess I would like it to be sort of like I would have it here at the bottom, right? I would have the fraction part, and I would have the number of leading zeros. So what would it be? It's bytes, yeah. Start up to I is what I would like to have. And then I would also somehow need to get... well, I guess I would actually know it up here, right? I would write down start up here, and then I would know this is like the leading zero, I guess, and I can just do math. But I do have to like add by 1. Whoa. Okay, so yeah, I need to do this. I'll just make it simple for this. Write it this way. So here's the first digit of the fraction. me just make it leading zeros. Why are you learning Rust? You not? What? Do I spell this with an O or not? Yeah. I just feel like the E looks better. Adding up leading zeros. So otherwise start is here. If I have leading zeros, I would do I'm gonna check start again. Or no, I'm counting things. So this would be this could not run at all, which means start is behind. Watch party. I'm working. I'm working. I'm not watching that. I also still don't know what that is. What do you mean, let's go? I said I'm not watching that. You misheard me. Leading zeros. I count up leading zeros. I'll just write skipping zeros. Watch the episodes. The last one is I'm not gonna watch them. I don't think I'm gonna watch those. You very well are. No. Probably not. I can just tell by looking at it that I don't want to watch it. Why do you hate clown girls? Sorry. I just know that it's not my thing. Am I losing it? Did I... Am I fried now? I think I am. I think I'm fried. Skip the leading zeros. If we run out, we stop. Don't do let. Skip leading zeros. So I will be pointing to a non-zero thing, but I could break out and if I only get zeros, why is this one so strange? Because I could read only zeros. I would know that I read only zeros because okay, I have to check if the digit I'm looking at is between 1 and 9. And if it is, then I do something. If I is greater than or equal to size, then I'm done. But I need this check in here. This is the thing. I would actually like to be able to break out to a different thing. But this whole thing isn't in a loop for me to break out of. So if I is greater than or equal to size, I need to, or rather, if I is less than size, I can still do stuff. Alright, so this all can go in here. I've still got things to do. I can do this. Match bytes I. This is kind of more like another if, so if... I don't know. This is just nothing. Yeah, this has just gotten this has gotten really bad really fast. So I think I need to save I here, because I could be looking at something that is nothing. So I would do start to I, or start plus leading zeros to I. What are you upset about? Okay, I'll just make it a U size then. Fine. Okay, so if this whole thing doesn't run, it was not a decimal. Start would be I, leading zeros would be 0, so this would just be I to itself, and it would be empty. Oh, as I get in here, I add I to 1, I add 1, and now a start is here. So start, and then let's say I don't read any zeros, and well, okay, I read a digit. It's like the digit 1. And I think I do have to add 1 here, though. I should be pointing at... I should be pointing at... So I've certainly read something. You know what, let me do this. Just test if value is not in a range. Range contains. Is there a simpler way? So I have to do dot contains. Okay, sure. If we do not have a digit, okay. Now this drops out 2 layers. Okay. A little bit easier there. So if we're not in this range, that's a bad thing. There needs to be a digit after a dot. Skip the leading zeros, counting up. So I is now pointing to let me do this. I feel like this might be a little bit easier because I kind of want to do more like a do and while thing. Now, what is the difference between these two? I don't know if there's any. In fact, I actually don't know why I wrote that now. Skip me a second. I don't know what I saw. So the thing is, I could have changed here. And I guess it still comes down to this. This check needs to be here still. So I've skipped all those leading zeros. Start is now pointing at the first digit. In fact, I don't really need to do that until down here before I start changing it. And I guess I can combine these. There must be a digit after the dot. So start is now the first digit. And then I've counted up leading zeros. And then what is this? This is progressing I while Yes, it is. Oh no, this is just continuing and counting up I until I hit a non-digit. So that's what this is doing. Let's do another while I is less than size and yeah, that's just it. It's just doing that. Drop all that out. I guess I can just write a loop. And I think I'd rather write a match because I don't know. I feel like somehow that'll just be like it might be able to optimize this better somehow. Although it probably should produce the same thing. So then I will do a loop. If I is greater than or equal to size, I stop. Otherwise, I compare the current thing. If it's here, I go to the next one. So now I is pointing to the first non-digit. And then I have the fraction part. And so the fraction part here would be digits at this point. Well, let me say whole digits. And I say let fraction digits equal to I minus start plus any zeros. And in fact, I guess I can just do length of this. It's kind of unnecessary, maybe. I can just write that. Okay, so now a fraction part that could be empty. It won't be empty. I've guaranteed it won't be empty. This must have something. Okay, not necessarily, because if it wasn't even a period, then start is equal to I and leading zeros is 0. So this would just be empty, and this would say it's 0 length. And then at this point, I guess I do this check. So now I see if I've exceeded. If I've reached the end, then now I need to say I need to do something. So I guess what I can do is just add the fraction part to the whole part. And what should I do if the value is too large? Well, what happens up here when the value is too large? I kind of just let it be whatever it was going to be. This multiplication. This could also be a problem. Well, actually, because these are floats, float doesn't have any concept like that. So I think what happens is you just end up with infinity. Infinity. Which I'm going to say is fine. If the number's too big to fit into a float, then it becomes infinity, that's fine. All right, so what I would do is I would say yeah, I think I might just do this. I might just write macro here and say here. And then this entire thing. Let me parse first 19, then multiply by an exponent of n digits. Okay. So now this becomes get whole. These two things. Now what's the issue? I don't need that. I need this. What? This is really weird. There's just some broken parentheses. Okay. So there's all that, and then I would say get fraction. Yes, the fraction's gonna have, well, my idea here is that I reuse the whole part and I just add the fraction part. I'll just go with it because I see a problem that's going to come when I get to reading in the exponent value. But I guess that one's pretty easy. I just read in the exponent value and I would take the whole the combination and raise it to that power. Whoa. Fraction digits 20 safe to fit into U64. So I get the fraction part. Oh, there's only parts the first 19. And then I would ignore the rest. And then I would take this whole result and do what with it? I would take the whole result and raise it to I need to treat it as a fraction, right? So the number of digits that I have is how far I need to move the decimal. And then I need to move an extra by okay. Power F, and then I'll just write this and see if it raise it to the power of no, I multiply it. Okay, let me make these like this. Times negative fraction digits plus leading zeros. And then this would be get whole plus get fraction. Again, almost a problem. Arguments are incorrect. As float 64. Cannot apply a negative to a U size. Can we get real? Okay. So if I have one fractional digit, I would do 10 to the negative 1. So I would take that, move it over. If I had one fraction digit and one leading 0, that'd be adding them together. So I go 1, 2. All right, I think this is correct. So if we're at the end, return the whole plus the fraction. Okay. Getting there. Oh, and then I have the whole negative thing. So this would be get whole would be um um problem, hopefully. Oh, and this is just always going to be that now. I'll just do... Oh, no, I definitely want to... I want to do... I want to apply sign to the entire thing, not a portion of it. Okay. I would like to use the double brackets. I'd like to use the double. Whoops. This one I guess isn't needed because I have this wrapping it. I apply a sign by taking the whole, add the fraction, and now I can read an exponent. And in fact, it would be if I is greater than size, or either of those two are valid, I would just return. I guess I should probably collapse these. I'm gonna collapse those. Okay. So I know for a fact the next one is an E, so I can add 1. If at this point, though, we're greater than size, this is a problem. We have to have something after that. And if I get a plus or a minus, I tick forward. So I'll say let say if is exponential negative or it's positive. I'm skipping it, and then I can be sure that I'm still good at that point. And then I have a check at this point that I need a digit. And how many times I have to like keep checking for digits here at this point? It gets a little crazy. I must have a digit after that E or sign. Now, I am counting up how many I see, which would be this. So yeah, now here I would say start is going to be equal to I, and then I count digits. Take these comments. I'm gonna do the same thing as the fraction. I will skip leading zeros. So I'll just set leading zeros to be 0 here. So I can be sure that when I get there, good. If we hit the end, a stop start is I, and then I will be incremented by 1. And then if I'm outside, I'm done. The first thing I'll do is actually skip the leading zeros. So I'll do like a while. I'll copy this. Yeah, and I say while that is 0, I count this up until I'm done. And then I would loop like that. Match 0 to 1, I plus 1. And I guess I can simplify this a little bit. Okay, is this right? This should just be identical to how I did the fraction. So let's do this. I do start is equal to I. And then I set leading zeros to be 0. And then I go through this loop, just like that. And then I go through there, just like that. Okay. I think I may as well write I feel like I may as well write a macro, honestly, to do this, because it is identical and I want it to be identical. Cool. All right, so now I have the exponent, and now everything comes together. So yeah, I guess it's just yes, the exponent is going to be a multiplier. So it would just be 10 to the power of that. I'll say, oh, I'm just going to write this down. So it'd be really similar to this. And then trailing digits will amplify the value as well. I'll write it out. Where is it? Here. Okay. So this would be this sign to... In fact, I'm actually just gonna... Okay, so there's something happening here where it's actually gonna be like the whole. Okay, so it's gonna be really similar to the whole part. Where I'm doing it like this. So I'm getting the exponent as a value. So we'll actually just do this. If I have fewer than 20, leading zeros, trailing zeros, everything, that's all fine. If I whoa. Oh wait, no, this one's hang on. So this one, it's like both of these. I have to do this and then I have to raise it to this power. Oh, no. Leading zeros don't have any meaning on it. It's only the trailing zeros that have meaning. So as I read in the first 19 that I have, And then I would do that. Let me see digits and part. Any other early returns here? And I'll just make apply sign. Take in the negative. So I can drop this one, which is kind of dumb. Okay. So now get exponent is, yeah, not even necessary now. So at this point, I could just do apply sign of is negative to a thing here. We get whole of digits whole part. Add the fraction, which handles its precision, and then I would need to add or this entire thing. It now needs to be raised to a power. Raised to the power of apply sign is exponential negative. Jeez. To get whole of exponential part, or exponential digits, and then part. And then I guess that's the formatting it really wants to have. And then whole handles raising thing to a power given the number of digits that are left. Great. All right, so in theory, I just now have to make parse int actually handle this. This does use wrapping multiply, but it doesn't matter. If it overflows, then... Okay, it not necessarily like that. I know that I'm not going to get more than 19 digits. I know that for a fact. So I don't care about wrapping here. So just keep this going, and then I would do and then I guess at this point it would be like if size is still positive, then I have one more to do. Okay, so at 4, remaining like I'm probably able to just kind of and these are actually all going to be ifs instead. So if size greater than 4, because of how I'm splitting it, I know that the last section will be 7 or fewer. So if I take 7 minus 4, the size will be left at 3. The largest value could be. So the rest can just be ifs. Current U32. So the idea here is I'm reading in 4 digits like this. U32. And I guess these all kind of stay the same, where I just cut the front off. Because that's how it would be collapsing. But then this final shift I would not be doing. In fact, I think I'm not doing these last two at all. Yeah. I'm skipping those. And then this result would be moving the number up, I guess, just 1,000. I guess that's actually 10,000. Well, it actually would be these steps, right? Yeah, I stop at the shift by 16 because I don't need to. I've zeroed these out, and I shift this one into this place, and then it's done. With 2. These 2 bytes would go away. And then I just do this shift and this multiply vanishes. And then I would take the current result and I have to move it up. Like so, I think. Yeah. And then at this point, remaining is already the value. So I'll just write remaining. In fact, it's from big Indian bytes, so I don't even really need to do that. I'm not doing this. This would go away. I don't need to subtract size anymore. Remaining is the last byte. So it would just be multiply by 10. Is this excessive? Maybe. I've heard that branching is no good. But I mean, these aren't really branches, I guess. It's not branching in the sense that if I don't do this, then I do something else. It's more like if I don't do it, then I do nothing. Right, and what's wrong at the top? Okay. Okay, parser test. Let's try parse number. Or I guess now at this point I can just write it out. So yes, we'll do let number. I have to do right. A JSON number be equal to JSON parse 1, 2, 3, 4, 5. Parse just say unwrap else panic no, and then I will print the number. Got 12393. Huh. Very close. But it's also definitely not right. So is it like, I mean, let me just check the ones, I guess. You got 49. Yeah, that's not right. Okay, what about 20? Can you do 20 correctly? 20 is correct. What about 2000? You got 2000. What about 2060? 90. Okay, so it seems like it can get these ones, and then I'm guessing it'll be able to do the 8. So the 8's perfect. Okay, so I have a problem with the 1. Nine five nine oh 18. Yeah, okay. So it looks like I've just got a problem with the 1. Where the 1 isn't. Yeah, yeah, I did forget that. I did forget that. I need to do a mask there. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 0.9. 1, 2, 3, 4, 5.9. E to the 1. Which I think should round it up 1, I think. Okay, it did not go 1. No, because e to the 0 should do nothing. Okay, then it says it got 1. Okay, so that's wrong. Why did e to the 1 not work? Times power applies sign, get whole exponential digits, exponential part. Count digits. Okay, let me just do print line. Empty. A 0. 0 implies times 10 to the 0, which is 1. So it should just be 1. Well, I mean, this shouldn't be 1. It should be this multiplied by... Right. It's this times 10 to the power of that number. That's what it should be doing. Run. Okay, the 9 went down 1. Why'd the 9 go down 1? Because that's correct. It would have gone that way. 2. Right. 1. This should have just been the same number, though. But now it says 09. Should be 4.59. So is the problem that... Well, what's the problem then? Because it should just return 0. But it's done something really odd. Where I've got a 0.09. I'm adding these two together and then I multiply the whole thing by this. times 10 to the power of apply sign. If it's all zeros, then what's happening? Okay, let me print the number that I get every time. Okay, wait. So result is this. Size would be 0. So I do end up just returning 0. I'll print. So I read a 1, 2, 3, 4, 5, I read a 9, and then I read a 0. And then I get this God is now wrong. Oh, I think I understand, because what it's doing then is it's reading that in and then multiplying it by 10 to the power of 0 minus 19. So I need to make sure that no, because if it's 0, then we do parse int and it returns that. This is the number of real digits. Okay, what is going on? Okay, let me just, for now, print out just this. Just this. What do you think is the exponent? 0. Got 0. Good. That's correct. So then, what do you think is this? Or well, I guess now the question is, what do you think this is? This should be 1. Got 1. Okay. So then, what do you think this is? Is get fraction doing something here? Fraction digits. Oh. Oh. I need to know that. Okay, so what I'll do is I will do let fraction leading zeros equals leading zeros. I'll do that, because these are important. So instead I do, I'll just keep it all like this. So I do digits part Now this should be right. So I should just see the same number out. Good. Now -1, so I want to move this over to the 5. I'm okay with that. That's, you know, that's just floating point precision. That's fine. -2. Cool, -3. Good. -4. -5. -200. Whoa. Okay, well I cannot count that. But you know, I'm just gonna assume that's probably right. That's probably correct. You can't see all the zeros. It's just so many zeros. Okay. What about like that? What do you think about that? That thing. The same way. A positive should make no difference here. And then I do a 1. And then I do a 10. And then I do... Is that 10? Okay, that's 10. And then I do a really big number. What do you think about that? That's gonna be infinity. That should be infinity. Got infinity. Okay. 100. We can still store 100. 300. 308. This should be too far. Cool. So why is that the exponential part? 51, 48, 56. Yeah, that doesn't make any sense. I don't know how that happened. Okay, what is the maximum value I can put in here? So this value should be representable. So hopefully I can represent the value. Okay. It looks like it did it. If I were to go even 1 digit higher, infinity? Okay, no, it just still wrapped it. Interesting. So at what point does it get upset? Okay, so it got mad there. Okay. 2. Infinity. Alright, now what about all these subnormal numbers? I can't remember what the subnormal numbers look like. I think they're like, I can't remember. Here they are. So yeah, this is the smallest value that you can represent. Let's see if I can do that one. I get the number, the exact number that I wrote in right back. Now is it going to be the same thing where if I At what point do I have to decrease this value before it tells me it's 0? I'm guessing this will tell me 0. Let's just jump straight to that one. 2, 1. It's a bit weird. It is a little bit weird. How would I actually make this go lower than that? Because obviously it can represent these values. Yeah, how would it... Wait, how are these numbers working? Okay. These are the subnormal numbers. Is it the lowest value? Okay, well, what's this one? 5E324. Okay. Alright, 5E324. Let's see if I can get that one. It's the smallest float that I can write in there. Okay, that one just came out as 0. I mean, I guess that's... Is that fine? The subnormals are difficult to represent. Let me try this one. Okay, that one came through. So where's the threshold? Can I still do this one? I am losing a digit at the end every time. If that's the case and I'm just losing like a digit, then... Okay, I could still represent that. Which is... I'm happy. I mean, at that number, I'm happy. This is at the edge of what is even like useful math at this point. You basically can't. You pretty much can't even use these numbers. They're too small on floats. Doing anything to them would instantly drop the exponent and like raise them back into a normal number. Okay, so this looks like the limit. I mean, if it's like this close, I guess what I could do, if I really wanted to, because what it's looking like is I lose these bits. So as soon as I hit here, this has gone too far. Somehow I'm dropping the last, maybe not. It's actually still representable. This could even just be a string, a number to string problem in Rust itself. It may just not be able to even display this. Okay, well, I can actually go all the way down here. Can I do 1E? I've got it. I've got the full range. It looks perfect to me. Okay. That's cool. It is time for me to be done. But this is great. So I'm getting a number every time I tried out the really difficult things. What about negative? There's a negative sign. It just seems like the last one I can't do this one. This one, or just Rust won't print it. It just prints this as 0, which is also possible. I could print out the exact bits, but I mean, I'm fine. I think not being able to represent this single value, I'm okay with that. That can probably be like a hack fix later or something for that specific input. Okay. That's it for today, though. Thanks for watching. I will be back tomorrow with the crawler bot. Get back into that. Yeah, get a number parser. Now, I don't know if it's really fast. It's technically using a very fast algorithm. I've demonstrated it to be really fast, but I've not demonstrated this to be really fast. So maybe, I mean, and I can just swap it out too. So I can just swap this out for the slower version, which just runs through and sees what happens. Yeah, I mean, I guess I can do that. All right. I'm gonna do that on my own. Thanks for watching. I'll be back tomorrow. Goodbye.